Hello students, welcome to Educate. We are going to do numericals on the chapter dual nature. So here the first question is find the maximum frequency and minimum wavelength of X-rays produced by 30 kilo electron. So let's evaluate it. So we are given energy E equal to H nu equal to 30 into 10 power 3 into 1.6 into 10 to the power minus 19. Is it okay? Now, here our concern is to find the frequency. So, frequency can be evaluated and then we can find the wavelength. So, nu will be equal to 30 into 1.6 into 10 to the power minus 16 divided by 6.63 into 10 to the power minus 34. Let's simplify. So 30 into 16, here two places of decimal are there. So let's write it 160 divided by 663 into 10 to the power. From here it will become 18. Right. So we can evaluate it. So on evaluation we will get 7.24 into 10 to the power 18 hertz. So this is value of frequency. Now C equal to nu lambda we can apply to get lambda. So let's put the values. C is nu times lambda, which gives lambda equal to C upon nu. So C is 3 into 10 to the power 8 divided by frequency. We have just evaluated 7.24 into 10 to the power 18. Correct? So this will become 300 divided by 724 into 10 to the power minus 10. Correct? So this will come out to be 0.41 into 10 to the power minus 10 meters. So we have got the value of wavelength. In terms of nanometer also we can write. So now let's see next question. Question number 2 says the work function of cesium metal is 2.14 electron volt when light of frequency 6 into 10 power 14 hertz is incident on the metal surface. Photo emission of electron occurs. What is the maximum kinetic energy and the stopping potential, maximum speed of emitted photo electrons? So we can easily find by using Einstein's relation. So that is H nu is equal to kinetic energy plus H nu 0, which is work function. So here our concern is to get kinetic energy. So H nu minus H nu 0. So H nu, what is H nu? 6.63 into 10 to the power minus 34 into given frequency 6 into 10 to the power 14 minus work function is given 2.14 electron volt, means 1.6 into 10 power minus 19. So 6.63 into 6 into 10 to the power minus 20 minus 2.14 into 1.6 into 10 power minus 19. Here this will become 6.63 into 0.6 into 10 power minus 19, 2.14 into 1.6 into 10 power minus 19. Here 10 power minus 19 we can take out. 6.63 into 0.6 minus 2.14 into 1.6 whole times 10 power minus 19. Now we can evaluate it. So on evaluation we will get 0.54 into 10 power 0.54 into 10 to the power minus 19 joule. So this is maximum kinetic energy. We can convert it into electron volt also. And as we know that stopping potential and maximum kinetic energy both are same, so both will have same value. Now we have to find out the maximum speed. So for maximum speed, we can use the concept of kinetic energy 1 by 2 mv square equal to the kinetic energy so obtained is 0.34 into 10 to the power, not this value, 0.54 into 10 power minus 19 or 0.34 in terms of electron volt, 1.6 into 10 to the power minus 19. This is same thing. And here our concern is to get velocity. So 2 into 0.34 into 1.6 into 10 to the power minus 19 whole divided by mass. Mass is 9.1 into 10 to the power minus 31. So we can simplify, we can remove decimals. So 2 into 34 into 16 divided by 91. Let's count the number of decimals. This is 2, 3 here, 1 here. So 2 more zeros are needed here, and then 10 power minus 19 plus 31. Right. So 2 powers will reduce. So this will become minus negative 21, giving 10 power. So how much? 2 into 34 into 16 divided by 91 into 10 to the power. So this will become minus 21. So this minus, so this will become plus 10. And then we can take square root to find the velocity. Correct? So we can get the velocity from here. Next question says the photoelectric cutoff voltage in a certain experiment is 1.5 volt. What is maximum kinetic energy? So as we have studied that maximum kinetic energy is given by E times V0, where V0 is cutoff voltage. So it's given here. So E is electronic charge 1.6 into 10 to the power minus 19 times V0. V0 is 1.5. So this will become 2.4 into 10 to the power minus 19 joule. So that is the answer. Now let's go to next question. Next question says monochromatic light of wavelength 632.8 nanometer is produced by helium neon laser. The power emitted is 9.42 milliwatt. Find the energy and momentum of each photon in the light beam. How many photons per second on the average arrive at the target irradiated by this beam? Assume the beam to have uniform cross section which is less than the target area. And how fast does a hydrogen atom have to travel in order to have the same momentum as that of the photon? So let's evaluate it. So here energy, find the energy and momentum. So we have to find out the energy. So energy E is given by E equal to h nu or hc upon lambda. In our question, what is given? In our question, wavelength is given, right? So h is 6.63 into 10 power minus 34 times 3 into 10 power 8 divided by lambda is given as 632.8 into 10 to the power minus 9. Right. Now we can evaluate it. We can remove decimal places. 663 into 3 divided by 63280 into 10 to the power. This will become 17. We can simplify. So what more is missing here, and this minus 34, right? Let's evaluate it. So on evaluation, we will get 3.14 into 10 power minus 19 joule. 3.14 into 10 to the power minus 19 joule, correct? And next part is we have to find out momentum P equal to H upon lambda. So we can evaluate. So what is H? What is lambda? So H is 6.63 into 10 to the power minus 34, and lambda is given in our question as 632.8 into 10 power minus 9. That is decimal places we can remove. So here one place, here two place. So 663 divided by 63280 into 10 to the power from here. So this will be minus 25. Further we can simplify. So we will get 1.05 into 10 to the power minus 27. So P will be 1.05 into 10 to the power minus 27 kg meter per second, correct? So this is value of momentum. Now next point is how many photons. It means the same concept we have to apply as we have studied in case of example. So number of photons. So we can say power is equal to number of photons into energy per photon. So this is per second. So we have to get N. So N is equal to P divided by E. So we can put the values. Power is given in our question 9.42 into 10 to the power minus 3 into energy each photon we have already evaluated. So that is equal to 3.14 into 10 power minus 19. 3.14 into 10 to the power minus 19. So we can evaluate it. So this will come out to be 3 into 10 to the power 16 photons per second. Did you understand? It's simple. 3 is a, we will cancel out. Okay. And then how fast does a hydrogen atom have to travel in order to have the same momentum? So we can apply the concept for hydrogen. So momentum of hydrogen P equal to mv. So here our purpose is to find, so P equal to mv. Here v is to be found. So P upon m. So we have already evaluated the value of momentum 1.05 into 10 power minus 27 and divided mass. Here we are talking about hydrogen atom. So mass of hydrogen atom is 1 protonic mass 1.67 into 10 power minus 27. So we can evaluate it. It will be around 0.63 meter per second. I think you have understood. Now, we are going to see next question. Next question says, in an experiment on photoelectric effect, the slope of the cutoff voltage versus frequency of incident light is found to be 4.12 into 10 power minus 15 volt second. Calculate the value of Planck constant. So if we plot the graph between, this is stopping potential and this is frequency, so graph will be like this. So here on extrapolation, this axis is intercepted by this line. So we can say the equation that we have already studied, V0 equal to H upon E times nu minus, here there was some constant. This is from the equation EV0 equal to H nu minus H nu 0. right? So V0 is equal to h upon E nu minus h nu 0 upon E. So h nu 0 upon E, right? So here this is work function, so we can also write phi upon E. So h upon E nu minus phi 0 upon E. So this is constant here. So our concern is this is slope h upon E. In our question, what is the value of h upon E? Here question says we are given in the exportable the slope of the cutoff voltage versus frequency of this light is this much. So h upon E is given this much. We have to find out Planck constant. So it's simple. So let's write h upon E is equal to the value so given 4.12 into 10 to the power minus 15, or h equal to 4.12 into 10 to the power minus 15 into 1.6 into 10 to the power minus 19. If we evaluate it, it will come out to be 6.59 into 10 to the power minus 34 joule second. Correct? Now, let's see next question. So, what is next question? The threshold frequency for a certain metal is this much. If light up frequency this much is incident on the metal, predict the cutoff voltage for the photoelectric emission. Cutoff voltage means we have to find out the maximum energy. From there, we can get the cutoff voltage by dividing the electronic charge. So we can say we are doing question number 6. So threshold frequency of the metal is this much. So h nu equal to h nu 0 plus kinetic energy, or h nu 0 plus EV 0, right? Here our concern is cutoff voltage. So cutoff voltage means V0. So V0 can be found by h nu minus h nu 0 divided by E. So 6.63 into 10 to the power minus 34 outside. Nu is given 8.2 minus 3.4 into 10 to the power 14 whole divided by electronic charge, 1.6 into 10 to the power minus 19. Right. Now we can evaluate it. So on evaluation, we will get it as 2.03 volt. So that is our answer. So this is all in this video. We will study question number 11.7 onwards in next lecture. Thank you for watching. Team Educate.